Okay, we're given universal set A, B, C, D, E, F, G, H, G, elements being those letters. Given the set A, whose elements are the letters A, B, D, and G. Set B, whose elements are the letters C, D, F, and H. Now, we want to ask a couple of questions, kind of overall questions, but we'll come back to them in a minute after we've done some more elementary questions, but everybody has done the quiz at answering some of these questions and did more or less well on it. Okay, so my question is, which set among those that you worked through is A prime intersection B prime equal to? And also, how can you tell from the values of n of A, n of B, and n of U, that is the cardinalities of the set A, set B, and set U, that A union B cannot be equal to U? Okay, some people, it's pretty easy to do. Some people had a little oversight and concluded that A union B was equal to U, without thinking about this, of course. But that gave rise to this question I want to pose. Also, people were asked to fill in the blank here. What's the meaning of what question that they might want to pose? Okay, and I'll try to answer some of those questions in videos. Okay, well, back to this now. We want to find the set A intersection B. Well, the intersection is all the elements in the universal set which are in both A and B. So we could go through the universal set. We could say, okay, let's see. A's in the universal set. Is it in both A and B? Well, it's not in B, so it's not in the intersection. What about B? Well, it's not in set B, so it's not in the intersection. What about C? Well, it's not in set A, so it's not in the intersection. What about D? Well, there it is in set A, there it is in set B. Oh, okay, so it goes into the intersection. It's going to turn out to be the only letter that goes into the intersection because none of the remaining letters occur in both sets. Okay? Now, another way to do that is just take one of the sets. So you don't have to check every member of the universal set. Take the smaller of your two sets if one is smaller. That's not the case here. The sets are the same size. But let's just take set B, okay? Let's check out the element C. It's in the set B, so it'll be in the intersection if it's also in A. But C is not there in A, so C is not in the intersection. What about D? Well, there it is in A, so it is in the intersection. What about F? Look through A, it's not there. H, look through A, it's not there. Okay, I don't have to look at anything else. I don't have to go up through the elements of A and see if they're also in B, because I've already checked all the elements of B to see which ones are in A. Okay, so that's it. So I close off my braces, brackets, and I get the intersection, which is just a set consisting of the element D. Okay. Now, next question is A intersection B prime. That means the complement of A intersection B, which means everything that's in the universal set that's not in A intersection B. So how do I do that? Well, first of all, I go to A intersection B and I look at the universal set. Okay, if it's in the universal set and it isn't in A intersection B, then it goes down here. Okay. A's in the universal set. A, the letter A, it's not in the set A intersection B, so it goes in the complement. B is in the universal set. It's not in A intersection set B, so it goes in the universal set. The letter C is in the universal set. It's not in A intersection B, so it goes into the complement of the intersection. The letter D, well, that is in the intersection, so it's not going to go into the complement. And then we can check out E, F, G, and H. We find that none of those are in the intersection, so they will also appear in the complement. So these letters, which is all the letters in the universal set, except for D, the letter that's in the intersection of set A and set B, be present in the complement of A intersection B. So now A intersection B doesn't contain anything that, the complement of A intersection B here doesn't include anything that's in A intersection B, but it includes everything else in the universal set. So it's everything in the universal set that's not in A intersection B. Okay, now we ask the question A prime intersection B prime. What's an A prime intersection B prime? Well, we don't want to try to reason that all out based on what we have so far. We want to do this in two steps. So the first step I take is I first list A prime, which is this set, and then I list B prime, which is this set, and I do the intersection of those two sets. And I come to my conclusion. Now let's look at the details. How do I get A prime? A prime is everything that's not in A. So, well, let's see. A contains A and B, letters A and B, so those members of the universal set are not going to be in A prime. But C does not appear. C in the universal set doesn't appear in A, so it goes into A prime. D appears in A, so it's not going to go into A prime. E doesn't appear in A, so it will appear in E prime, A prime. F doesn't appear in A, so it's in A prime. G appears in A, so it doesn't appear in A prime, but H is not in A, so it's here. Now we can go through the universal set and see which members also occur in set B. It turns out that's C and D as well as F and H. The remaining letters in the universal set are A, B, E, and G, so that's our B prime. And now we want to do the intersection of A prime with B prime. So we test, let's start with the letters in A, the elements of A. A contains the letter C, B prime doesn't. So C is not in the intersection. Remember that the intersection consists of everything that's present in both sets. What about E? Well, yeah, E occurs over here, so E will go into the intersection of A prime and B prime. Okay, what about F? Well, F doesn't appear over here, so it's not going to be in the intersection. H doesn't appear here, so it's not going to be in the intersection. And we're done. Right there is the intersection, A prime intersection B prime. What about A prime union B prime? Well, again, I write down A prime and B prime, but I put a union between them, which means that everything in the universal set that's in at least one of these goes here. Going through the universal set, A and B both appear here, so they're going to appear in the universal set. C appears here, so it's going to be in the universal set. D, well, D doesn't appear in either of these, so it's not going to appear in the universal set. But then E appears here, F appears here, G appears here, H appears here. Every one of these appears in at least one of the two sets, A prime, B prime. So they're going to appear in the union of A prime and B prime. Okay, now let's go back to this question. I'm going to continue this in the next video. Which of these sets? One of these sets is equal to A prime intersection B prime. Well, actually, I've actually done A prime intersection B prime. There's another set in the set of problems that were given that also has the same members as A prime intersection B prime. And I'm going to change this question a little bit for the next problem. I'm going to make that a union, and we'll explore that question.